Every home has a history written in the soil it sits on. My home sits on a former volcanic zone in Virginia's Culpeper Basin, created by the forces of plate tectonics. Its history is recorded in rock layers deep below the foundation. Each chapter spans millions of years in what scientists call deep time. Tectonic plate theory explains how Earth's outer shell is made up of massive pieces, called tectonic plates. 7 major and many smaller plates. These plates move slowly, less than an inch per year, the rate fingernails grow, causing earthquakes, forming mountains, and shaping our planet's surface. Over millions of years, continents collide or drift apart, creating the diverse landscapes we see today. 300 million years ago, most of Earth's continents were merged together in one supercontinent called Pangaea. Notice the outline of the United States and state boundaries. North America's east edge was in the middle, welded to North Africa's west side, and located south of the equator. 60 million years later, when dinosaurs were small and just beginning to develop, Pangaea began slowly breaking apart. Notice that Pangaea has moved northward, with Virginia now located on the equator. This northward movement will continue, as the tectonic plates that carry the continents respond to the push and pull of tectonic forces. By 230 million years ago, rifting in the Earth's surface is evident on the North America-North Africa margin. Hot upwelling magma thinned the deeper crust below, causing the surface to swell upward, pull apart, and subside into rifts surrounding a volcanic hot spot. From South Carolina to Newfoundland, several rift basins began opening. These basins, shown in white overlay on the map, include Virginia's Culpeper Basin, and are collectively known as the Newark Group. Similar rifting is occurring today in the East African Rift Zone. Tectonic forces have been at work for several million years that will eventually separate East Africa into a new continent several million years in the future. This photograph by a NASA astronaut of the Rift Valley near Kenya's southern border shows numerous fault lines where the ground has been displaced and opened. A volcano is at top right. The land is arid with little green vegetation. The rifting of Pangaea created the Atlantic Ocean. By 220 million years ago, the opening is evident. It might have occurred in the Newark Group basins, but instead broke through in similar basins miles eastward. As the basins widened and deepened, erosion of rocks on higher land was carried by water, wind, and gravity into the low places. Streams, swamps, mudflats, and lakes formed and dried up, again and again, as the weather cycled through wet and dry periods. Layers of mud, silt, organic material, and sand built up and were themselves buried by new erosion layers. Layer built upon layer slowly and persistently, eventually growing miles thick. Accumulating weight, pressure, and heat welded the eroded material into mudstone, siltstone, sandstone, shale, and other rock types. By about 200 million years ago, the break between North America and North Africa was nearly complete. Upwelling magma broke through the floor of the rift basins, flowing up through cracks, heating and changing the rock it touched into other new rock types, and in many places erupting and flowing onto the surface of the land. The nascent Atlantic Ocean continued growing. Though narrow, by 170 million years ago, it is fully established. Upwelling magma in the mid-ocean ridge relentlessly pushing the North America and Africa tectonic plates farther and farther apart. Fast forward to today, the continents and the Newark Group basins are in their current positions. The Atlantic mid-ocean ridge is evident in light blue color more than 1,000 miles east toward Africa and Europe. Narrowing the focus now to Virginia's Culpeper Basin. The basin is outlined here. It is more than 112 miles long, 12 miles wide, and up to 5½ miles deep. The basin extends from south of Culpeper northward across the Potomac River to Frederick, Maryland. Washington, D.C. is to the east. The Blue Ridge Mountains are the first major ridge to the west. Looking at the basin's below-ground geology, with imagery from U.S. Geological Survey reports, the basin's structure is what's called a half-graben, where one side has dropped down with the opposite side nearly stationary, like a hinge. In this subsurface profile, the wide dashed line marks the basin floor, which sits on much older basement rock. The deepest point at this location is about 4,000 meters, or 2.5 miles. From right to left, multiple rock layers laid down, then tilted by tectonic forces. About 200 million years ago, in rifting's final phase, magma surged through cracks in the rock layers, indicated here in red. Where it did not break through to the surface, the magma solidified, forming diabase rock, its heat metamorphosing adjacent rock into new types. Where it did break through, the magma flowed onto the surface, cooling, and forming basalt rock. 5 basalt layers created in 13 separate magma flows to the depth of about 1/2 mile. Changing the view from the vertical depths to the surface, here the basin is displayed in AU.S Geological Survey bedrock map. Turned 90 degrees counterclockwise, with north now on the left. The basin's major rock groups are in different colors identifiable in the legend. The effects of volcanic activity are evident in the wide distribution of diabase, shown in dark pink, thermally metamorphosed rock, colored blue, and basalt, in light pink color along the west border where my home is located. The Culpeper Basin was created over 30 million years of the late Triassic and early Jurassic periods. An account of that geologic history would be incomplete without dinosaurs, which roamed the basin and left their footprints in muddy soil that became rock. The largest footprints so far discovered are as much as 12 inches long and 8 inches wide. Like size 15 men's shoes, but twice as wide. The 3-toed, clawed feet belong to small bipedal theropod dinosaurs. Fossil footprints of dinosaurs and other extinct animals have been discovered in several locations throughout the basin. 2 well-documented places where scientists have studied dinosaur footprints preserved in basin rock are Oak Hill, historic home of 5th U.S. President, James Monroe, in Aldie, and the Culpeper Luck Stone Quarry. At Oak Hill, now a private residence, footprints are preserved in patio and walkway stones, quarried close by. The Culpeper Quarry contains thousands of footprints, at one time the largest known collection of dinosaur footprints in the world. Luckstone opens its doors to dinosaur enthusiasts once a year in partnership with the Museum of Culpeper History, an opportunity so popular that the museum conducts a public lottery to award tickets to lucky winners. As you can see, my home has quite a history written in the soil of the Culpeper Basin. A former volcanic zone that formed when Pangaea broke apart about 200 million years ago. Tectonic plates that move slowly beneath our feet, shaping and reshaping the Earth. The basin's rocks and fossil dinosaur footprints from the Triassic and Jurassic periods provide a fascinating glimpse into the geological history of the region and the diverse and dynamic environment that once existed here.